students, this is your Prasanna ma'am from NEET World. Now we are going to discuss the most important topic both for NEET and MCET, that is floral characters from the chapter Morphology of Flowering Plants. If you take this chapter Morphology of Flowering Plants, you can read it in 3 fragments beta. What is that? First is vegetative characters, then floral characters, then you will learn about families. In vegetative characters, of course, you will be learning about root, stem, leaf and its modifications, right? And in floral characters, you have to focus on the flower, its position, its symmetry, estivation and placentation. These are the areas to be focused, and you know what families to be learnt. Now we are going to discuss about floral characters. Definitely every year the question will be appearing from 1 or 2 questions will be appearing from floral characters from Morphology of Flowering Plants. So, if you look into a flower, flower which is said to be the reproductive unit of angiosperms. What is the reproductive unit of angiosperms? Flower. Okay. In flower you have 4 whorls beta. How many whorls? 4 whorls. 2 are essential or reproductive structures those are andrecium and gynoecium. And what ma? Gynoecium. And 2 are non-essential whorls, which include calyx and corolla. Okay. So, here if you see, the stalk which is bearing a flower is said to be pedicel. What do you call the stalk as ma? The stalk is said to be pedicel. The stalk which is bearing a flower is said to be pedicel. Okay. And over the pedicel, the one which bears the structure of a flower is called as receptacle or thalamus. Receptacle or thalamus will bear the flower. Okay, and this flower has 4 segments. What 4 segments or 4 whorls? What are the beta? Calyx or sepals. Calyx is also said to be sepals, and petals. Okay, petals or corolla. Okay, calyx, petals or corolla. And andrecium and gynoecium. Andrecium includes stamens. Wherein it has a long filament and anther over it which will disperse the pollen grains. Okay. Andrecium includes stamens. Stamens has a long filament and anther which will disperse the pollen grains during fertilization. If you look into gynoecium, gynoecium can bear single carpel or many carpels. Based on that, we will learn about monocarpellary or multicarpellary gynoeciums. Okay. So, here in a carpel, in each unit of carpel, you will have stigma, style and ovary. The basal part is called as, basal bulged part is called as ovary, and stigma which is receptive for pollen grains, and this long tube like structure will carry the pollen tube. Okay, it will carry the pollen grains through the pollen tube to the ovary. Clear beta? So, carpel is the unit of gynoecium. Each carpel includes stigma, style and ovary. Clear with the structure of a flower? So, on a single flower, if both andrecium and gynoecium are present, then it is said to be a bisexual flower. If at all only andrecium is present inside a flower, then you will be calling it as a male flower. If only andrecium is present inside the flower, you will call it as a male flower. If at all only gynoecium is present in a flower, then you will call it as female flower. Then you will call it as what beta? Female flower. Clear? Clear with the structure of a flower? Now we will be learning the symmetry of the flower. Before learning the symmetry, in few plants, for example, the plants belonging to the family Liliaceae or lily plants. Okay, the plants belonging to the family Liliaceae or lily family. Okay, so here calyx and corolla are not distinct or differentiated. What happens beta? calyx and corolla are not distinct. They are not distinct or differentiated. So this condition you will see in which family? Perianth you will see in which family? The questions might be asked, okay. It is observed in the family Liliaceae, okay, wherein calyx and corolla are not distinct. They are in a single structure which is said to be perianth. What do you call it as, ma? Perianth, okay. Next, it is said to be perianth. Fine, clear. So if at all a question comes, in which family do you see, okay, do you see indistinct calyx and corolla? In which family do you see indistinct calyx and corolla, or calyx and corolla will not be differentiated? In which family he will be asking? Then your answer should be in Liliaceae, and that structure is called as perianth. Clear, ma? Next, if you look into the symmetry of the flower, asymmetric, wherein through any plane you cannot divide the flower into two equal parts, okay. Asymmetric means what, ma? Through any plane you cannot divide the flower into two equal parts. For example, kanna, okay. For example, the plant name is kanna, belongs to asymmetry, okay. Actinomorphic, which is also called as radial plane of symmetry. It is also called as what, ma? Radial plane of symmetry, which means like you can divide the flower into two equal parts by any plane, okay. By any plane you can divide the flower into two equal parts, then it is called as actinomorphic. For example, chili, mustard and datura. You can remember it like CMD, okay. CMD, okay. Actinomorphic, which means like radial pattern of symmetry, wherein you can divide the flower into two equal planes, into two equal halves by any plane. For example, CMD, chili, mustard, datura, okay. Next, zygomorphic. You can divide the flower into two equal parts only by one plane, okay. By only one divisional plane you can divide the flower into two equal parts. For example, pea, bean, acacia and gulmohar, okay. Pea, bean, acacia and gulmohar. Now if you see clearly with images, actinomorphic flower, chili, mustard and datura. If you see in chili, just a second beta, yeah. If you see in chili, okay, see by two divisions, by two divisional planes you can divide the flower into two equal parts, okay. And here also by two planes you can divide the flower into two equal parts. Here as well in datura, by 1, 2, 3, by 3 planes you can divide the flower into two equal parts. So under actinomorphic, what examples you have learnt? Chilli, mustard and datura. Chilli, mustard and datura. Clear beta? Zygomorphic, if you consider, you have to divide the flower in only single plane, okay, which means bilateral symmetry. What does zygomorphic flower symmetry means? Bilateral symmetry. Only by single plane you will divide the flower into two equal parts. For example, pea and bean, which mostly follows which type of aestivation beta? Vexillary aestivation. Now we are going to discuss aestivation also. Acacia and gulmohar. Pea, bean, acacia and gulmohar, wherein the flowers are divided by a single plane. I hope this is more clear with the images, right, ma? Now if you look into the next slide, it is of number of floral appendages. Based on number of floral appendages also we have given names. If it is trimerous, the floral appendages will be 3 or multiples of 3, okay. If it is trimerous, floral appendages will be 3 or multiples of 3. Tetramerous, floral appendages will be 4 or multiples of 4. Next, pentamerous, floral appendages will be 5 or multiples of 5. Based on, we will say like the flower is tetramerous, trimerous or pentamerous. Next, if you take, yeah, the parts of a flower includes, in the very first slide we have learned, right, wherein it includes 2 accessory whorls or non-essential whorls, those are calyx and corolla, and 2 essential whorls or reproductive structures, they are androecium and gynoecium. If you look into calyx, calyx include what beta? Sepals. Calyx include sepals. Okay, calyx includes sepals. Sepals are green structures which will protect the flower in the bud stage. It will protect the flower in the bud stage. Okay, it will protect the flower in the bud stage. And if all the sepals are united, then you will call it as gamosepalous. If the sepals are free, not attached to each other, then you will call it as polysepalous. What you will call it as, beta? Polysepalous. Okay. Now, if you see, yes, the sepals will protect the flower in the bud stage. If they are free, you will call it as polysepalous. If they are attached or united with each other, then you will call it as gamosepalous. And there is one term called as persistent calyx. You will look into this term when you are learning about the family Solanaceae. Okay, when you are learning about the family Solanaceae, wherein usually in all plants the sepals or calyx will be degenerated after the fertilization. Post fertilization, you will not find any sepals or calyx. Okay, but then in few members of Solanaceae, for example tomato, brinjal, okay, for example tomato, brinjal, the sepals are appeared. You know, you can find the sepals even after fertilization, even after the fruit formation. You can easily distinguish the sepals, you can easily observe the sepals. Sepals are present even after fertilization and fruit formation. Even after the fertilization and fruit formation, sepals are present, sepals are persistent. Here comes the term persistent calyx, which means sepals or calyx, sepals are present even after fertilization and even after fruit formation. Okay, clear ma? So here what you have learned, gamosepalous, polysepalous and persistent calyx. Very important, Nana. Persistent calyx is seen in which family? Solanaceae. Examples tomato, brinjal. You have to remember. Next, yeah, corolla also if you take, in corolla also you will find if they are attached to each other, if the petals in corolla, what do you see? Petals. Petals, if they are attached to each other like this, then it is gamopetalous. If they are attached to each other, it is gamopetalous. If they are free from each other, like this, then it is polypetalous. Okay, gamopetalous and polypetalous. And petals are mostly useful in, the prominent role that petals or corolla will play is attracting insects during pollination. The prominent role they play is attracting insects for pollination. Clear ma? Next, if you see, there are different shapes of the corolla, like you know, tubular or disc tubular form of corolla. See, this tubular pattern you will observe in the Asteraceae members. You will see tubular corollas in which members? Asteraceae members. And funnel shaped corolla you will observe in Datura. Funnel shaped corolla you will observe in Datura. And ocimum, bilipped shape you will observe in ocimum. Okay, bilipped shape you will observe in ocimum. And apart from that, you will also see bell shaped corolla and you will also see wheel shaped corolla. These are different shapes of the corolla. Need not to remember the example, children. This is like extra information for you. Okay. So yes, what you have to remember here, the prominent role that petals or corolla will do is attracting insects for pollination, and if the petals are attached to each other, it is gamopetalous. If they are free from each other, it is polypetalous. Now, yeah, here comes the concept of aestivation, which is 100% important. Definitely the question will come from this area. Okay, aestivation. What does aestivation mean? Okay, the mode of arrangement of sepals and petals in a flower is called as aestivation. What is aestivation, ma? The mode the mode or arrangement, the mode or arrangement of sepals and petals in a flower is called as aestivation. Valvate aestivation, which means that the sepals or petals will just attach to each other. They are one beside the other, but no sepals and petals are overlapping above one another. If you look this image, one petal is at the side of the other petal, one sepal is also at the side of other sepal. You can see here, one petal is just side by side, they are attached to each other. Okay, their sides are attached to each other, but nowhere they are overlapping with each other. The example here you have to note down is calotropis. The example is calotropis, and the image of the flower is over here. Okay, here if you see, the petals are side by side to each other, they touch each other, but petals are not overlapping each other. Okay, so here in valvate aestivation, what you have to remember, beta, petals are side by side to each other, they attach each other, but then no petals are overlapping each other. Example is calotropis, very much important, do remember. Okay, example is what, ma? Calotropis. Next, twisted aestivation, where you will see the sepals or petals are overlapping each other. Here petals are overlapping each other in a particular direction. Petals are overlapping each other in a particular direction, in the same direction you can say. Petals overlap each other in the same direction, and here the example you have to remember are lady's finger, China rose and cotton. What you have to remember, beta? Lady's finger, China rose or hibiscus and cotton. So yes, what is valvate aestivation? Petals just attached to each other, they will be side by side to each other, they are not overlapping. Example is calotropis. What is twisted aestivation? Petals overlap each other in a particular direction or in a same direction. For example, lady's finger, China rose and cotton. Next, if you see imbricate aestivation. In imbricate aestivation also, petals overlap each other, but not in a particular direction. Petals overlap each other, not in particular direction. So if you look into here, see, this petal is towards the inside and this is towards the outside. They are in one direction again. Okay. So if you see here clearly, one petal is interior and the other is out towards the outside, whereas the other three overlapping each other. So here petals are overlapping each other, but they are not in a particular direction. For example, cassia and gulmohar. Imbricate aestivation. Clear, ma? Next, vexillary aestivation. This is a very standard pattern of aestivation where you have to remember, and this is observed. This is a characteristic feature in Fabaceae, which is also called as Leguminosae. Okay, in this family, this type of aestivation is a characteristic feature wherein you will have one standard petal like this. Okay, you will have one standard petal. Here also you can see one standard petal, two wing or keel petals side by side. Here you have now two wing or keel petals, and lastly two attached joined at the below. Okay, these are called as two wing petals which are side by side after standard petal. Two wing petals which are not attached. Lastly, two keel petals. Okay, two keel petals, two wing petals and two keel petals. Yeah. So, here if you see in vexillary aestivation, what is the characteristic feature? One standard petals, two side by side wing petals which are not attached, and niches are two keel petals which are overlapping each other. Clear ma? So, yes, one standard, two wing and two attached keel petals. This is the characteristic feature of axillary aestivation, and you will observe axillary aestivation in the members of Fabaceae. You can clearly observe that here in the pea flower and in bean flower. In bean flower, if you see, this is the standard petal, these two are wing petals, and this downwardly these two which are attached are called as keel petals. Here if you see the standard petal in pea flower, okay, and two wing petals, and closer or down to that you have keel petals which are attached. Yes ma? Next. So, with this we have done with the aestivation. What aestivations we have done? One is, okay, we have done with valvate aestivation, example is calotropis. Twisted aestivation, examples are lady's finger, China rose and cotton. Next. Imbricate aestivation, cassia and gulmour. Vexillary aestivation, you will see that in Fabaceae members or leguminosae, for example, pea and bean. Next. Andrecium. This is the next structure. Yes, now we have completed with the accessory words or non-essential words, calyx and corolla, and their mode of arrangement also, and 4 types of arrangements of calyx and corolla, that is what ma? Valvate, imbricate, twisted and vexillary aestivations we have done, and you have to remember those examples, very much important. Now, andrecium. Andrecium consists of stamens. Andrecium consists of what ma? Stamens. It is composed of stamens. Stamens will have one long filament, above filament it has anther, one long filament, above that it has anther. Anther is bilobed, it has 2 lobes. Anther is bilobed, it has 2 lobes, lobe 1 and lobe 2. Each lobe will have 2 theca. Each lobe will have how many theca beta? 2 theca. Each lobe will have 2 theca. Inside each theca, microspores are present, they get matured and they will release what ma? Pollen grains. In each theca, you will have microspores, they are matured and they will release pollen grains at the time of fertilization. Okay. So, here if you see, anther in most of the angiosperms is bilobed and each lobe is having 2 theca, they contain microspores. Once they are matured, they will be releasing pollen grains. And here if you see, stamens of andrecium can be one or many. Okay, andrecium can contain one or many stamens. So, these stamens, if they are in a bunch, okay, these stamens if they are in a bunch, based on their attachment, okay, based on their attachment of stamens, we will call it as cohesion. Attachment of stamens is said to be cohesion. If at all stamens are attached to sepals, stamens are attached to petals or stamens are attached to the gynoecium, then it is called as adhesion. Then it is called as what ma? Adhesion, which is very important concept of andrecium. Okay, andrecium is composed of stamens. Stamens, if they are attached with each other, based on that attachment we again have monodelphous, diadelphous, polyadelphous, that is different. If they are attached to each other, only stamens attached to each other, we are calling it as cohesion. If stamens either attaching to the petals or they are attaching to the gynoecium, we will call it as adhesion. If stamens attaching to the other floral parts, in a simple terms, if they are attached to other floral parts, we are calling it as what ma? Adhesion. So, yes, adhesion includes adhesion and cohesion. Now, we will look into it. And if at all in any stamen anther there are no pollen grains only, it is not releasing any pollen grains, then it is called as staminode. What is staminode? Sterile stamen. Okay, what is staminode? Sterile stamen is called as staminode. Okay. Andrecium, just now we have discussed about cohesion and adhesion. Adhesion, if stamens are attached to petals, you will see it in brinjal. Okay, epicalyx or persistent calyx condition also you will see it in brinjal only. Okay, Solanaceae members. Do remember families whenever I am telling you, because questions will be asked from families and the examples only. Okay, epipetalous condition means what ma? Stamens attached to the petals. Stamens attached to petals is called as epipetalous condition, and you will observe it in brinjal or Solanaceae members. Epiphyllous condition. Epiphyllous condition. Initially we have learnt, no, calyx and corolla not distinct. You will see perianth. If they are not distinct, you will see perianth in Liliaceae family members. So yes, if stamens are attached to the perianth, if stamens are attached to the perianth like this, then it is called as epiphyllous. So in the point of adhesion, what did you learn? Epipetalous and epiphyllous condition. Epipetalous you will observe in Solanaceae members, for example brinjal. Epiphyllous condition where stamens are attached to the perianth, you will observe it in Liliaceae members, for example lily. Now if you see the andrecium cohesion, okay, cohesion wherein three types you will see: monadalphous, diadelphous and polyadelphous. Monadalphous wherein all the stamens of that andrecium, okay, all the stamens of the andrecium are in one bunch, then it is called as monadalphous. You will see that in China rose. Monadalphous, all the stamens of that particular flower, okay, all the stamens of that andrecium are in one bunch, then you will call it as monadalphous. You will see it in China rose, okay. And diadelphous wherein stamens are in two bunches, okay, stamens are attached in two bunches, okay, one and remaining 9 are in one more bunch, okay. If you see two bunches in the pea plant, Fabaceae members, Fabaceae, okay, diadelphous condition is seen in what ma? Fabaceae members, diadelphous condition, pea and bean, okay, wherein you will see two bunches of stamens, one bunch has only one stamen and the other bunch has 9 stamens, okay. Clear? This is the pattern of diadelphous condition. Polyadelphous wherein the particular andrecium of the flower will be having so many bunches, okay. Stamens will have more than 2 bunches, okay, more than 2 bunches, then it is called as polyadelphous. For example, in citrus you will see how many bunches you have. The microscopic view has shown in citrus 1, 2, 3, 4, approximately 4 to 5 bunches, okay, in citrus. Next, here if you see, based on the variation in the length of stamens, based on the variation in the length of filament also, filament of the stamen, also there are two types. What are they? Salvia and Brassica, which belongs to the family Brassicaceae or Cruciferae, which belongs to the family Brassicaceae or Cruciferae, okay. The filament length will be varying in the same flower, okay. If you find 2 to 3 different lengths of stamens or 2 to 3 different lengths of filaments, then it is called as based on the variation of the length of filament. The examples include in this and this plants you will observe such kind of variation in the length of filament. Those are Salvia and Brassica, which belongs to Brassicaceae and Cruciferae. Next it is Gynoecium. We have already discussed Gynoecium consists of carpels, okay. Gynoecium consists of what ma? Carpels. Carpels. Each unit of carpel, one unit of carpel will have 3 structures. What are they? Stigma, style and ovary. Stigma, style and ovary, okay. Stigma is the receptive structure for the pollen grain, okay. Stigma is what beta? Receptive structure of the pollen grain. Followed by stigma, pollen tube will arise across the style. Pollen tube will arise across the style, and the basal bulged portion is ovary. Basal bulged portion is ovary. Inside ovary, in the placenta of the ovary, inside ovary there will be placenta, which inside placenta we have ovules. Okay, post fertilization ovules will turn seed and ovary will turn to fruit. Post fertilization ovules will turn to seed and ovary will turn to fruit. Okay, na ma'am? So the basal bulged portion is called as ovary. Inside ovary complete placenta will be there, and inside placenta ovules will be arised. Ovules post fertilization will turn to seed and ovary post fertilization will turn to fruit. Clear? Now, if you see gynoecium, which is also called as pistil, okay, gynoecium which is also called as pistil, gynoecium consists of many units of carpel. If it has only single unit of carpel, only one carpel, then it is called as monocarpellary. If it has more than one carpels, okay, if it has many carpels, it is said to be multicarpellary. Multicarpellary can be apocarpus and syncarpus. Apocarpus means stigma, style and ovary, they are free from each other. All the carpels are free from each other. If you can see here clearly, you can see different stigmas over here, okay, which are free from each other, that is apocarpus. Okay, for example, lotus and rose. For example, lotus and rose. Here in syncarpus, if you see, mustard and tomato, wherein gynoecium or the structures of that are united. Okay, gynoecium structures are united. Okay, for example, stigma, let me draw a picture, stigma, style and ovary. One more thing like this, stigma, style and ovary. Like that, the stigma, style and ovary or the carpels are united to each other, they are attached to each other, then it is syncarpus. Clear ma? Example is mustard and tomato. Here the examples for apocarpus, lotus and rose. Examples for syncarpus, it is mustard and tomato. Next, if you see, yeah, placentation. Placentation is nothing but the arrangement of ovules inside the ovary. What is placentation ma? Arrangement of ovules inside the ovary. Where are the ovules arised? Ovules will arise in the placenta of the ovary. If you take this, the basal bulged portion in the carpel, okay, here completely it has what ma? Placenta. Okay, in placenta ovules arise, okay, ovules arise and they are arranged in a particular pattern. Okay, based on the arrangement of ovules, we have different types of arrangements of ovules, that is said to be placentation. If you take marginal placentation, okay, marginal placentation, the ovules arise, if this is the placenta of, if this is the placenta, the ovules arise from the ventral suture of the ovary. Okay, the ovules arise from the ventral suture of the ovary, that mode, and they are in a ridge. The ovary is in a ridge and ovules arise from the ventral suture of the ovary, then it is called as marginal placentation. For example, pea, bean and all the members which belongs to Fabaceae. If you look into axial placentation, wherein the ovules are arranged in the locules, okay, the ovules are arranged in the chambers or locules, which is called as multilocular ovary. Okay, the ovules are arranged in chambers or locules, which is said to be multilocular ovary. For example, China rose, tomato and lemon. Okay, next comes the parietal placentation, wherein the inner membrane of the ovary, the inner membrane or the inner wall of the ovary will be giving rise to, or here the ovules are formed. Okay, ovules are in the inner membrane or on the inner wall of the ovary, and sometimes though the septa is not there, there is no septa to differentiate the locules, but a false septa arises, and it reflects like two chambers, that is why it is called as false septa, which differentiates into two locules or two chambers. This is parietal placentation. What is parietal placentation ma? The inner wall, ovules arise in the inner wall of the ovary, and sometimes, for example, in the family, most important or characteristic feature of this family, Brassicaceae, wherein ovules arise in the inner wall of the ovary and there is one septa which is not formed. It seems to be like a septa and two chambered. Okay. So, that is why it is called as false septa, not a true septa. Okay. Next, free central placentation. The ovules are arranged freely inside the placenta of the ovary and not attached to the any membrane of the ovary. Okay. The ovules are attached inside the placenta of the ovary freely without attaching to any membrane of the ovary, then it is free central placentation, for example dianthus and primrose. Lastly, it is basal placentation, where you will see it in sunflower and marigold. The ovule is present or ovule is formed at the basal part in the placenta of the ovary. The ovule is arised or formed in the basal part of the placenta of the ovary. Okay. That is basal placentation. Now, if you look into the examples more clearly, very important, very important. The examples of aestivation, the examples of andrecium we have discussed, the examples of syncarpus and apocarpus gynoecium, and the examples of placentation must asked question every year. Definitely you will get 1 or 2 questions. So, focus. Okay. Marginal placentation P. Next, axial placentation China rose, tomato and lemon. Parietal placentation you can remember mustard and argemone. Okay. Free central placentation dianthus and primrose are the examples. Basal placentation sunflower and marigold. So, this is all about today's session and coming up with most important topic again. So, stay tuned. Thank you.